In this video, we will talk about the friendship in C++. We will cover two types of friendship, function friendship and class friendship in C++. We will then use two code examples in order to enforce the learning. In principle, private and protected members of a class cannot be accessed from outside the same class in which they are declared. However, this rule does not apply to the friends. Friends are functions or classes declared with the friend keyword. A non-member function can access the private and protected members of a class if it is declared as a friend of that class. This is only done by including the declaration of this external function within the class with the friend word preceding that member. Let's take a look at the code and see how it actually works in action. So, over here, I already have developed the code, so let's go through it and see what's going on. So within this code, I have a class, which is a class rectangle, and I have a rectangle function defined down here, and then I have my main. Let's go back up. As you can notice, class rectangle has two private members, width and height. And then there are two public constructors. One of them is no args constructor and the other one is two args constructor down here, which simply they set the width and height to x with this one, and with the other one there is no initialization happening. And then there is an integer area which basically returns nothing but width and heights times each other. So the product of width and heights are going to be returned in that integer area. Then here is the key point that I want you to be careful about, and that's how the friend function duplicate is being defined. So look at how it exactly happens. So it starts with the friend keyword, then the class name, which is going to be used as an identifier, and then the name of the function, which in this case is the duplicate, and then of course the signature of the function and how the function is going to receive the parameters. In this case, it's going to receive a pointer to a rectangle. So now outside the class, and look, this is the scope of the class. So these private members are already accessible within this class scope. And of course, because we are defining the friend function right inside the scope, now this friend function is going to have access to those two. So now let's look at how the rectangle is defined down here. So the rectangle duplicate, which is saying that the duplicate function is of the type rectangle, is keeping the same type of definition. We're sending the parameter over here. And down here, we just create an object of the class rectangle. And then we set the width and height of that object to whatever parameter we get and has a width and height, but this time we multiply it by 2. So basically what happens is an object of the class rectangle is going to be referenced to this function, and whatever the width of that object, in this case param is going to be multiplied by 2 and be set to the width of the res, which is the object of this function. And then the height of the res is going to be set to height of the param times 2. And then the object res, which is already created, will be returned. And that's as simple as it can get. Notice two things. We are accessing a private member here and here of the class rectangle, which are these two guys. But obviously there is no problem because this function is defined to be a friend within this class. So that's as simple as that. Now in the main, so we basically are creating an object of the class rectangle, name it foo. So when you do this is what will be called, and then we create another one, name it bar, and when you do it this way, this constructor will be called. So in this case, the 2 and 3 are going to be set to the width and height. And then for the other object, which basically is not set up yet, we are calling the duplicate, which is a friend function, and we are passing this object bar, which is already set with 2 and 3, to that duplicate function. Let's come back here in the duplicate function. It receives the bar and then creates an object res, which basically is going to be returned back to the foo. And over here, res.width is going to be bar width, which is in this case 2 times 2. So the value for that guy is going to be 4. And the same thing happens for 3 here, which is going to be multiplied by 3, and therefore it's going to be 6. So the width of the res is going to be 4, which is twice this guy through this calculation. And the height of the res is going to be 6, which is this guy times 2 through this calculation. Now, what I have is 4 and 6 returned back to the object foo. So in the cout, I'm getting the area of the foo, which is going to be this function, and returns 4 times 6 in this case, which I'm expecting to get a 24. Again, notice that neither in the declaration of the duplicate nor in its later use in the main, function duplicate is considered a member of class rectangle. As you can see here, I don't have foo.duplicate because duplicate is not considered a member. It's not a member function. It simply is not. It only has access to its private and protected members through this definition. So don't let the place of this definition make you to make a mistake. We define it inside, but this function is not a member of rectangle. You will never find any document that calls this a member of rectangle. So now let's run this code, and we expect to see a 24. So I'm running the code, and as you can see, number 24 shows up, which is the duplicate of 2 and 3, and then again multiplying them and getting the product. So typically, friendship is used when friend functions are operations that are conducted between two different classes accessing private or protected members of each other. So basically, you have two different classes and they have to kind of talk to each other for whatever reason. And when those objects want to access the other class's private or protected members, you can use friendship so that you don't need to go through a lot of getters and setters and all those hassles that you have experienced before when you started learning the classes and objects. So similar to friend functions, a friend class is a class whose members have access to the private or protected members of another class. There are two caveats to always remember. Friendships are not corresponded unless specified. So if you have a function in one of the classes that is defined in the other class too, but the friendship keyword is not specified over there, that's not going to work. Another property of friendship is that they are not transitive. The friendship basically can only be seen if both classes agree that the friendship exists. The friend of a friend is not considered a friend unless explicitly specified. Okay, now let's continue looking at this through an example. Let's first read the code together and then we're going to come back and analyze it. So let me just put it over here so you can see everything. So at the beginning of the code, I'm defining a class square. And as you can see, I'm not defining anything within it, which I'm going to explain why later down the road. And then we have our class rectangle from the previous example, which has the width, height as its private members. And as you remember, even if I don't define them private, like remember in the previous example, we had it defined like this. Okay, even if I don't define it like that, they still are private members. So you can recall from the discussion about classes and structs that in classes, all the members are private by default unless otherwise is stated. So then we have the public integer area, which returns the width time height. And then we have a void convert, which basically accepts an object of class A, and there is nothing defined here yet. Okay, so then I have the class square, which I'm defining now. Look at that. Again, this was up here. I'm going to explain why. And then class square is being defined here with a friend class rectangle. So basically, I'm defining a friend class within the definition of class square, and that is the rectangle class. And there are one private member over here, which is the integer side within the class square, and a public square integer a, which basically returns the side. Then I have this void rectangle convert to square a down here, which creates a width and a height based on the object a, which is a square object sending to it and passing the side to it. In this example, class rectangle is a friend of class square, allowing rectangle's member functions to access private and protected members of a square. More concretely, rectangle accesses the member variable square side, which you see it over here, which describes the side of the square. There is something else in this example, as I said, which I did it for the first time, and that's defining a class square at the beginning, and that's empty. This is necessary because class rectangle uses a square as a parameter in member convert, and a square uses rectangle declaring a friend. So that's why I define it at the beginning, so when I call it over here, it is already known. And then, as you know, I'm completing that definition down here. I could have done this on the top, but then the problem was I was using rectangle, which was not defined beforehand. So I need to do this for one of them so that everything is already known for the compiler as the compiler goes through. Friendships are never corresponded unless specified, as we said. Look at this. In our example, rectangle is considered a friend of class square, but square is not considered a friend by rectangle. So let's see what I mean. So if you look at this square, rectangle is defined here as a friend class, right? But over here, we don't have a square being defined as, as a friend by rectangle. Therefore, the member functions of rectangle can access the protected and private members of class square. So these guys over here can access side, but it doesn't work vice versa. Of course, square could also be declared friend in the rectangle. So if I just define it over here, let's say that friend class square and type it down here, then a square is going to be friend and a square is going to have access. And this is only if the need be. Another property of friendship, as we said, is that they're not transitive. And over here, if we have another class which is friending with square, then it not necessarily will be friending with rectangle. And that's obvious, as we discussed before. So again, here, class rectangle is defined to be the friend, and that's why over here we can have access everything that is within this class. But this class does not have the same access. Okay, so that's pretty much the intro to friendship, and now you know how the friendship works, and this concludes this video.